24 stars hitting Earth? The Sun may have a companion star that periodically bombards Earth with storms of comets and asteroids, scientists from Lund University and the Swiss Federal Institute of Technology said Thursday.New studies of Earth's impact craters found asteroids tended to hit roughly every 26 million years, adding to evidence that mass extinction events could be driven by a dim companion star to our Sun named after the Greek goddess of revenge, Nemesis. Under this theory, the next apocalyptic asteroid will hit Earth in 10 million years. The evidence seems to have gone back and forth in recent years. NASA's planetary defense officer who helps devise plans for the U.S. government to stop an asteroid or comet, told the Daily Caller News Foundation. Nemesis theoretically has an extremely elliptical orbit, swinging by our Sun once every 26 million years, and redirecting the orbits of asteroids and comets to bombard Earth. Researchers have never found Nemesis, but such a star would be exceedingly difficult to detect. Nemesis would be a faint red or brown dwarf star, orbiting our Sun at a distance of about 1.5 light-years. The majority of stars in our galaxy actually belong to systems with more than one star. We see dwarf stars, but it is difficult to get the 3D orbital data for such a star in our galaxy as humans do not have the time base to predict such long-scale interactions even with great observational data, and that certainly does not exist for any but the closest stars. Dr. Joseph Nuff, a senior asteroid scientist at NASA's Goddard Space Flight Center, told the DCNF. Nemesis gravity could alter the orbits of swarms of comets or asteroids in the outer solar system, placing them on a collision course with Earth. Stellar interactions should affect toward cloud comets, not asteroids except as secondary products of a comet storm hitting the inner solar system, Nuth said. Basically you need a massive gravitational perturbation or lots of collides to get this. We probably can't handle a single asteroid on 5 to 10 years warning, Nuth said. A comet or asteroid storm coming with less than a decade warning would require dropping everything else and going to full defense as a planet, and it still probably would not be enough. The best way to stop an asteroid or comet from hitting the Earth may be to send a spacecraft up to intercept it. NASA, however, would need at least 5 years to construct a reliable spacecraft and man it. If more than one asteroid or comet were coming at Earth, stopping them all in time could be impossible. Impact of an asteroids as large as 1 kilometer in size are estimated to cause global effects, that is enough dust, debris and/or water vapor expelled into Earth's atmosphere to block sunlight and negatively affect the climate worldwide, Johnson said. An event that caused mass extinction would need to be significantly larger than that. In 2016, NASA and other federal agencies simulated a response to an asteroid striking Earth. Officials were unable to deflect an asteroid on course to hit Earth with 4 years of warning. An asteroid or comet wouldn't need to be that large to potentially wipe out humanity. The event 65 million years ago, the mass extinction of dinosaurs, is thought to have been caused by a 10-kilometer-sized asteroid. Our population models indicate we have already discovered all asteroids of this size currently within the inner solar system, that is within the orbit of Mars. The amount of damage an asteroid or comet impact could do is linked not just to the size of the object, but also to the geology of the area where it strikes. For years, paleontologists hypothesized that the size of a mass extinction might be correlated with the size of the bolide itself. Dr. Rowan Lockwood, a William and Mary paleontologist who studies extinction, told the DCNF. In recent years, paleontologists have realized that the geology at the impact size is probably more important than the size of the bolide. Asteroids big enough to cause a mass extinction should be roughly 0.6 miles in diameter. NASA outright admits there's not much the agency could do to stop such an asteroid on a collision course with Earth without advanced warning. See the Torino scale or the Purdue simulator, but it will generally depend on both size, density and mass, especially in the case of a comet, Nuth said. A dense fast comet many tens of kilometers in radius could certainly do it. Former NASA administrator Charles Bolden told reporters in 2013 that the only response to a large surprise asteroid on a collision course with Earth is to pray. Comets may come crashing on our Earth, as no less than 24 stars that are heading towards our solar system may deflect the space rocks, according to scientists. These comets may collide with the Earth in the next million years, researchers at Max Planck Institute for Astronomy in Germany have said. The stars stray into the Oort cloud, and researchers calculated how often they visit there. Oort cloud is a vast, spherical shell comprising of billions of icy objects that is believed to envelop our solar system. According to researchers, such close encounters can displace these comets, pushing them into the solar system and thus causing a risk of a collision course with the Earth. Within the next million years, between 19 and 24 stars will come within 3.26 light-years of the Sun, the team predicted, saying they will be close enough to deflect comets from their original paths. Certainly anything coming within that distance you should worry about, Corinne Baylor-Jones, of the Max Planck Institute, was quoted as saying by The Guardian. However, they said that not all close encounters would result in comets hitting the Earth. The collision would depend on the position of the Earth in its orbit relative to the passing star. However, chances of collision would peak at these time points, they said. Researchers said that the paper predicts that a further estimate 490 to 600 stars will pass close to the Sun within a distance of 16.3 light-years within the next million years. This is far beyond the predicted outer reaches of the Oort cloud, but in the case of a very large star, still potentially close enough to cause comets to swerve in their tracks, they added. The study was published in the journal Astronomy and Astrophysics. A 24-carat collision. All of the gold on Earth came from dead stars crashing together, claim scientists. Scientists reveal gold is created as the result of gamma-ray bursts. These bursts are created when stars die and collide with each other. When these collisions take place, heavy elements such as gold are released. The amount of gold produced when two neutron stars merge is as big as the mass of 10 moons. We value gold for many reasons: its beauty, its usefulness as jewelry, and its rarity. But perhaps we will treasure our gold jewelry even more now that American scientists have revealed that all gold on Earth was created when dead stars collided. The Harvard-Smithsonian Center for Astrophysics said that the precious metal is created as the result of a gamma-ray burst, which throws out substantial amounts of heavy elements. Gold is rare on Earth, in part, because it's also rare in the universe. Unlike elements including carbon or iron, it cannot be created within a star but instead must be born in a more cataclysmic event known as a short gamma-ray burst. One such burst was recorded last month. Observations of this gamma-ray bursts provided evidence that it resulted from the collision of two neutron stars. The dead cores of stars that previously exploded as supernovae. Moreover, a unique glow that persisted for days at the gamma-ray burst location potentially signifies the creation of substantial amounts of heavy elements, including gold. A gamma-ray burst is a flash of high-energy light from an extremely energetic explosion. Most are found in the distant universe. Berger and his colleagues studied gamma-ray burst 130603b in June, which, at a distance of almost 4 billion light-years from Earth, is one of the nearest bursts seen to date. Gamma-ray bursts come in two varieties, long and short, depending on how long the flash of gamma rays lasts. Gamma-ray burst 130603b was detected by NASA's SWIFT satellite on the 3rd of June and lasted for less than 0.2 of a second. Although the gamma rays disappeared quickly, gamma-ray burst 130603b also displayed a slowly fading glow, dominated by infrared light. Its brightness and behavior didn't match a typical afterglow, which is created when a high-speed jet of particles slams into the surrounding environment. Instead, the glow behaved like it came from exotic radioactive elements. The neutron-rich material ejected by colliding neutron stars can generate such elements, which then undergo radioactive decay, emitting a glow that's dominated by infrared light, exactly what the team observed. Wenfei Ifong, a graduate student at the CFA who is involved in the RISRAC, said, "We've been looking for a smoking gun to link a short gamma-ray burst with a neutron star collision. The radioactive glow from gamma-ray burst 130603b may be that smoking gun. The scientists calculate that about 1/100th of a solar massive material was ejected by the gamma-ray burst, some of which was gold. By combining the estimated gold produced by a single short gamma-ray burst with the number of such explosions that have occurred over the age of the universe, all the gold in the cosmos might have come from gamma-ray bursts." Professor Berger said, "We are all star stuff, and our jewelry is colliding star stuff." According to a Thomson Reuters GFMS survey, humans have retrieved a relatively small amount of gold from the Earth at around 172,000 tons. Most of it is unreachable in the Earth's core, but if the amount that has been dug up was made into a cube, it would measure about 21 meters on each side. How stars can cause comets to strike Earth. As many 24 stars are headed towards our solar system and may deflect comets, causing them to collide into the Earth in the next million years, scientists say. Researchers at Max Planck Institute for Astronomy in Germany calculated how often stars stray into the Oort cloud, a vast, spherical shell of billions of icy objects that is thought to envelop our solar system. Such close encounters can dislodge these loosely orbiting comets, sending them hurtling into the solar system, risking a collision course with the Earth. Researchers said. The team predicted that within the next million years between 19 and 24 stars will come within 3.26 light years of the Sun, close enough to deflect comets from their original paths. "Certainly anything coming within that distance you should worry about," Corinne Baylor-Jones, of the Max Planck Institute, was quoted as saying by the Guardian. Not all close encounters would lead to comets hitting the Earth. The collision would depend on where the Earth is in its orbit relative to the passing star. But the chances of a collision would peak at these time points. A further 490 to 600 stars will pass the Sun within a distance of 16.3 light-years within the next million years, the paper estimates, researchers said. This is far beyond the predicted outer reaches of the Oort cloud, but in the case of a very large star, still potentially close enough to cause comets to swerve in their tracks, they added. The study was published in the journal Astronomy and Astrophysics.